In this lesson, we're going to talk about perfect squares and square roots. So what is a square root? A square root looks like this symbol right up here. This is the square root of 25, which is equal to 5. And what it is it's a number that produces a specified quantity when multiplied by itself. So if I were to take 5 times 5, that would give me 25. So that means that the square root of 25 is that number that was multiplied by itself twice, which was 5. So to kind of show you a visual of what a square root is, I have these visuals right down here, and you can see this is what a perfect square looks like. Let's look at this first one. We can see we have a 3 by 3 square, so it has all side lengths of 3. And if we were to count the inside squares, you can see that we have 9. So if we were to take 3 times 3, that's going to give us 9. And 9 is a perfect square. It's also perfect because both side lengths are equal to each other. Just like the second one here, you can see that my side lengths are 4 all the way around my square. So since my side lengths are all equal, I can see that I'm going to have 4 times 4 is going to give me, let's see how many boxes it gives me inside my square. Looks like if I count them all up, it gives me 16 squares. So 16 is a perfect square. And then I have another example here. You can see my side lengths of 5. All the side lengths of the square are 5. So 5 times 5 is going to give me, and if I count up all those squares inside my box here, that would give me 25. So 3 perfect squares are 9, 16, and 25. Now let's look at something that is not a perfect square. Notice that the side lengths on this rectangle actually are 3 and 5. So obviously it's not a perfect square because it doesn't have the same side lengths. And if I were to multiply the numbers 3 times 5, that number being multiplied is not the same. So it can't be a perfect square. Same thing with the second example. I have 6 and 5 as my side length. And those two side lengths are not the same, so they can't be a perfect square. All right. So moving on. Let's talk about this idea of a rational root and also irrational root. A rational root is a number that is like an integer, or it can create a fraction, or a repeating decimal. So those numbers are called rational numbers. For example, if we look at the square root of 9, again, I'm looking for a number times a number equals that number. And so the square root of 9 is going to give me 3, because 3 times 3 gives me that number underneath, 9. And then the square root of 16 is equal to 4 because 4 times 4 is 16. 3 and 4 are both rational numbers. So these are rational roots. Now let me show you what an irrational root looks like, because this will kind of make it all make sense. These are numbers that are not perfect square values. In the other two, the square root of 9 and square root of 16 were both perfect squares. But let's look at the square root of 15. The square root of 15 does not have a number that I can multiply by itself to give me 15. And if I actually took the square root of 15, technically it would be something like 3.87, and it would go on forever. In no particular order. And then the square root of 30, same thing. It's something like 5.4772, and it would go on forever. They're not nice integer numbers. So these are called irrational roots. When you don't have that number to, like 3, you can multiply by twice to give you that 9. That's called an irrational root. So all irrational roots, if it's irrational, it can't be a perfect square. So let's look at this little section at the bottom here where it says, determine if the square root is rational or irrational. We want to circle the rational roots, basically the perfect squares, and we want to put a box around the irrational roots, the ones that aren't perfect squares. So what I'd like you to do is pause the video and try to do this activity on your own, and then start the video again and see if you were correct. All right, I'm first going to go ahead and I'm going to circle all of my rational roots. Everything that I am choosing here is rational. Hopefully you were correct. Those are all of my rational roots, meaning those are the roots that will give me an integer answer that is a perfect square. For example, the square root of 36 is 6. The square root of 49 is 7. The square root of 81 is 9. The square root of 100 is 10. The square root of 400 is 20. The square root of 144 is 12. And the square root of 121 is 11. Those are all nice integer values, perfect squares, very nice. Now the irrational roots are the other ones that I chose. These ones I'm going to put a box around. Now these ones were irrational because whenever I was trying to think, well, what number multiplied by itself will give me that number underneath, I couldn't think of anything. So these are the numbers that are irrational. All right. Let's go ahead and talk about all of our perfect squares and square roots. This year we're going to be studying all of the perfect squares and all of the square roots from 1 to 20. So let's just kind of go through them and you can see the similarity. So the 1 squared, well 1 squared is 1 times 1. That's going to give me 1. And on the other side, if I take the square root of 1, well the square root of 1 is also 1. 2 squared, well, 2 times 2 is going to give me 4. And the square root of 4 is going to give me 2. Okay, 3 squared, that's going to give me 9. And the square root of 9 is 3. 4 squared is going to give me 16. And the square root of 16 is going to equal 4. Hopefully you're seeing the pattern that it is developing here. 5 squared is going to give me 25. And the square root of 25 is going to be 5. 6 squared is going to give me 36. And the square root of 36 is going to give me 6. 7 squared is going to give me 49. And the square root of 49 is going to give me 7. 8 squared is going to give me 64. And the square root of 64 is going to give me 8. 9 squared is going to give me 81, and the square root of 81 is going to give me 9. 10 squared is going to give me 100, and the square root of 100 is going to give me 10. So hopefully you're seeing the pattern of how perfect squares and square roots are working together. All right, let's go ahead and, let's go ahead and do the 11 through 20. I'm going to go ahead and fill these out real quickly. Hopefully you're seeing the patterns that are working here. Go ahead and fill them in as I do. Okay, now those are all of my perfect squares and square roots. All right, and that is the end of our lesson actually. So this is a great video to just kind of look at and study your perfect squares and square roots. And these are definitely numbers that you want to commit to memory.